Oh, now we're going to get the echo of people in the courtyard. Okay, that's going to be fun. Anyway, back live. I'm live again. This chair should be over here. There we go. Cool. All right. Obviously, I was not here on Wednesday. That was kind of unexpected, but it is what it is. You guys had a substitute in the room, right? Just making sure. Somebody told me that at first there was like not a student, a teacher. A teacher told me at first that there was no teacher in the room at first. Okay, you're all nodding yes. Okay, so that was partially true. Okay. All right, whichever works. But yeah, it was kind of unexpected. The assignment that I gave you for Wednesday was to complete that quizzes that I gave you. Move that back a little bit. And then to read the chapter on chi-squared. Now, obviously, I have not taught anything on chi-squared yet. I am going to be taking a step towards that today. So hopefully in reading the chapter, a lot of these things will automatically be clicking or something along those lines. But again, I am going to be teaching it in full today, the concept of chi-squared and why it is needed. It is not going to be the only day on chi-squared because there's multiple tests that I have to teach within that chapter. But we're very much coming up on the end, if you can believe it. Chi-squared is chapter 25, and the book only goes up to chapter 26. So we are very much coming up near the end. Oh, who dare? I'm stuck in my cord. There we go. Okay. So, lost my train of thought because I got stuck in my cord. Anyway, so yeah, we were very much coming up in the end. It's gonna be fun. I think they sent this out. Did they send out a reminder email about the transportation for the AP test? Good. Now I'm not gonna ask. Obviously. I don't want to show of hands. I don't want any of that, but please make sure that you have filled out that survey for transportation for the AP test day. That is vitally important. They need to know. Because it's going to be coming up before you know it. I think we're going to be in the second window of AP testing, obviously. The first window of AP testing, I believe, starts sometime next week. In fact, I'm going to be proctoring one of the tests on A day. So that won't affect you guys. Yeah. So it should be interesting. Just as a heads up, you guys take yours on Tuesday, May 25th. I want to make sure we're all on the same page with this. And then I have you again on Wednesday, May 26th. Do you know what's happening the rest of that week? Yes. And you got a 5-day weekend. You got that Thursday and Friday off. Some of you are nodding yes, some of you are looking at me incredulously. Okay, good. I don't even know what incredulously means, but you have that 5-day weekend. Then, after that 5-day weekend, we are legitimately in June. And then, okay, we're moving forward. The rest of the year is going to stinking fly by. I wanted to clarify this because a few people have asked me, and I said, hold on, I'll explain it in due time. So let me explain it now. Final exams. Somebody asked, or several people asked me about final exams. There goes some paper. I'll get it later. They asked me about final exams and like, okay, what are we doing for AP Stat for a final exam? Is there a final exam in AP Stat? Long story short, yes, there is, but it is going to be in the form of a project that we would be working towards. What's going to happen after the AP exam on May 25th is we are going to begin working on certain portions of this final project for 3-4 straight class periods leading up to the week of senior exams. And I say the week of senior exams because obviously I do have seniors in here, and we should be able to get our exams done during the week of senior exams. So long story short, yes, there will be a final exam. It's going to be in the form of a project that we're going to be working towards. It's not going to be a big old test because you would have already taken your test for AP Stat. But of course, that test on May 25th, we won't know the results of that until July. But we'll figure that out. So I wanted to make sure we're all on the same page with that. No big test for a final exam, but a project that will count towards the final exam grade. And we'll get that thing done. Okay. So as I told people who are here and people who are in the chat, and if you haven't left a comment, please do so. I wanted the Chromebooks out because I wanted to review some of those questions from Wednesday. I wanted to review some of the multiple choice that you took. And I mentioned the multiple choice from Wednesday, and a chill goes down some of your spines because you realized, oh crap, I did not do too well on that multiple choice practice. I know, we'll get there. So what I've done is I went back to quizzes, and they have something, if I could bring up the right, there it is, bring up the right thing here, duplicate. They have this thing called instructor paste. Now, again, this is going to be practice, but what I would like you to do is I'd like you to log on with that code. And for those of you in the live stream as well, to log in with that code, you can see it. I think it's 617474. Double check. Boom. And I logged on as well because I would like to see the questions along with you. See, the thing is, this screen, I think this screen will show it. I haven't done many of these instructor paste ones. But I'm going to try it out together with you guys. We'll see what happens. But I would like to go over these questions with you because this kind of extends over the rest of the school year going back to September. So get yourself logged in. And of course, like I said, if you're in the chat and you haven't left a comment, I do see the 6 comments so far. That would be fantastic if you would. Give people opportunity to log on. Now, being that it's instructor paste, I haven't tried this yet, but I'm going to assume that they won't show you the next question until I opt to click to go to the next question, which will give people an opportunity to kind of get these answers. But these are the same questions that you saw on Wednesday. 4, 8, 6, 4, 8, 14, 17. Okay, I got 17 here. I got 6 in the chat. I got 15 logged on. You got to get in there. Once you get your name on that thing and you can like type your name or they give you the option, you got to click to join that thing. That's fine. Computer froze. I turned off my volume on that thing. Boy, I hate this full screen. Hold on. Get that full screen. Whatever, it's the same thing. Is anyone not able to get in? It's like 17 here, there's 15 in the thing, there's 6 in the chat. All right. They're joining in. Okay. If you have not joined, that code, I believe, should be at the top of the screen. Should be at the top of the screen. But the only way that you're going to be able to see the questions in full, is if you were actually logged on to this thing. Because I'm not sure what's going to go on with this thing up front. But let me click the start. Let's get this thing moving. Let's see here. Click. Okay, yep, the code is still there. Yeah, the code is still at the top right there. Okay. So click, I haven't done this review thing just yet. Click here to proceed. You can click through the arrow keys. Got it. Cool. And they show the dot plot. Oh, come on. Oh, there it is. Good, good, good. Okay, so one thing at a time. The dot plot displays the total number of miles that the 28 residents of one street in a certain community traveled to work in one 5-day work week. Which of the following is? Did they not let me see it? Full question view. Holy crap, that thing. Again, I haven't tried this one before. I wanted to see what it looks like. What's it look like on your screens? Just the regular question? Sweet. Okay. Which of the following is closest to the percentile rank of a resident from this street who traveled 85 miles to work that week? So now, they're talking about percentiles. There are 28 residents, 28 dots on this particular thing. If you were to look at this dot over here, don't worry about the number of miles. But if you were to look at this dot right here, this would be the maximum dot, 28th out of 28. That would be at the 100th percentile. If you were down here at this dot, this would be the first out of 28. So whatever 1 divided by 28 is in that case, 1 divided by 28 is going to give me some kind of a decimal here, 3.6%. That first dot would be at the 3.6th percentile. They want to know which is the closest to a percentile rank of a resident from the street who traveled 85 miles to work that week. Now right here, about here would be about 85 miles to work that week. Notice how they trolled you. They immediately trolled you and put 85 as one of the choices. 85 is not the answer. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. I've counted 8 dots above 85 miles. 8 dots above that many miles. There are 20 dots below. If you do 20 divided by 28, you get approximately 71.4%. 71.4%. Oh, sweet. It actually lets me know if you clicked it. So go ahead, click your answer. Those are weird symbols. Let's see. What happens if you don't click it? Because I have mine open right here. Like I joined. I think like this one's me. Oh, sweet. All right, let me click mine and see what happens. The what? All done. Yeah, that's cool. Haha. But yeah, 71.4%. They're talking about which one is closest. That would be 70% in this case. All right, so let's see what goes on next with this. So that's full question view, participants view, chart view, full question. Oh, that's cool. I've never done this one before. I'm just really interested. Next question. Obviously, they're not timed. We'll get this thing done. A simple random sample of people. Let me go to the question view. Well, you can see it on your computer screens, though. You can see it on your computer screens. A simple random sample of people aged 19 to 30 living in the state of Colorado was surveyed to determine which of 2 MP3 players just developed by a new company was preferred. To which of the following populations can the result of the survey be safely generalized? Well, let me get this door open here, get some cross ventilation. Hey, I did not time that. I actually thought you did. No. I did not time that at all. Yeah, get your Chromebook logged in. The code's at the top. So which of the following populations can the result survey be generalized? Now, immediately you might be thinking to yourself, well, it says a simple random sample of people living in the state of Colorado. It has something to do with Colorado. Well, either you think it has something to do with Colorado or you think it has something to do with people in the United States. But in reality, you really have to stick to people living in Colorado, which kind of limits us to these first 3 choices. People living in Colorado do not speak for the rest of the country. So it comes down to, okay, only people aged 19 to 30 living in Colorado who were in this survey. Only people aged 19 to 30 living in Colorado. All people living in Colorado. Well, it was a sample of people living in Colorado. Think about what a sample is designed to do. A sample is intended to find out more information about a general population. You cannot catch all the fish in a lake. You can only catch a sample of fish in that lake. Select what you think the answer is before. Yeah, there you go. I can see people starting to select their answers up there. Good. But pick what you think the answer is. And then I want to talk a little bit more about that. In fact, I'm going to select my answer as well. That was quick. Others are still answering. Okay. Still waiting on 2 people right there. Well, first of all, like I said, Because the survey was just limited to people in Colorado, there we go, you cannot assume that this represents the rest of the United States. As a result, these bottom two answers are gone. A lot of people might be pulled to answer all people living in Colorado. However, that's not the case because they limited it to just people living between the ages of 19 and 30. The answer is only people aged 19 to 30 living in Colorado. That has to be the population that you're referring to. I mentioned the fish in the lake situation. It's an example I did in the beginning of the school year where you talk about, like, I want to know what the average weight is of all these fish inside this lake. Okay, well, you can't catch every single stinking fish. You can't. But you can catch a small randomized sample, find the average of that, and that tells you something about the population. That's what this problem's referring to. You take a small random sample of people between the ages of 19 and 30 in the state of Colorado. That will tell you something about the general population of people aged 19 to 30 living in Colorado. Let's see. Click. Oh, there we go. Click. Boom. Let's see, full question view. Ho-ho, lots of words. Okay, thankfully you can see it on your screen. All right. Janelle collected data on the amount of time and minutes each person in a large sample of customers spent in a local store. The data also included recording the gender of each customer. These data were used to generate the box plots. Which of the following statements is true? My suggestion, before you even look at the choices, let's just take a look. It's the amount of time and minutes each person in a large sample spent at a local store. Okay? Time spent at that store. Clearly, the male population spent a bit more time. There's a couple of dots at the end. Could represent the outliers of this thing. I mean, obviously, we don't have... Well, I mean, we could potentially calculate an interquartile range. Yeah, we could calculate an interquartile range. But again, this is a multiple choice question. Maybe we need to do that later. We could figure that out. The median. Wow, that median is like even larger than the maximum for the females. And they have the same minimum. Okay, let me take a look at the choices. Let's see what we got here. Full question. This is terrible. Okay, I'm going to read them on my computer screen because these things are weird. Okay. The range in the amount of times. Oh, which of the following statements is true? Nice. Okay. Which of the range in the amount of times of males spent in the sample? Approximately 40 minutes. Okay, range, max minus min. The mean amount of time males in the sample spent in the store is approximately 20 minutes. Okay, but mean is not something that is expressed on a box and whisker plot. The third quartile of the amount of males in the sample spent is approximately 45 minutes. Okay, third quartile, we can identify that on a box. The interquartile range, which we can identify, the amount of time males spent in the sample is approximately 15 minutes, and then approximately half of the males in the sample of customers spent at least as much time in the store as any female in the sample of customers. Okay, you pick your answer. I'm going to pick my answer. Let me do a little quick calculation here in my head. Okay. I'm going to click this thing. Oh, it didn't click. Come on, click. There we go. I'm waiting for others to answer. Hey, is that cross ventilation even working? Okay. Okay. All right. All right. I kind of hoping, Sorry, I'm just laughing at the fact that this is like a modern high school with air conditioning. Hey guys, open your windows. Let me click back, see what that chart looks like. Looks like we almost got all 20 in there. Click. Click. There we go. I can see what most people picked in that thing. There we go. There's all 20, all done. And you can see which one ends up being correct. Let's talk about that. First of all, the range of the amount of time men spent in the store. Range is max minus min. Range is max minus min. Now, even though those outliers up there are considered stars, they are still data points within the sample. So if you're going to do max minus min for the males, that would be 90 minus 5. That would be 90 minus 5, not 45 minus 5. Those stars, yes, they are outliers, but they still count as data points. Let's see, the second one, the mean. Well, you can't tell what the mean is from a box and whisker plot. The mean is not a part of constructing that box and whisker plot. In order to construct that box and whisker plot, you need the minimum, the first quartile, the median, the third quartile, and the maximum. That's how you create that thing. And then if you can identify outliers, that's why they put them as stars at the end. The interquartile range of the males. Well, let's take a look at the interquartile range. If you're talking interquartile range of the males, this would be Q1, Q3. I'm not quite sure exactly what Q3 is, but I'm pretty confident that Q1 for the males is 10, which means that the interquartile range should be about 28, 29, something like that. But clearly not the option that they gave me. The answer has to be that last choice. The answer has to be that last choice. Can't even read it right now. It's covered by that thing. But it basically said that about half of the males was more than any of the females. And that is true. I think I even verbally pointed that out. The fact that here's the median. There it is. Which is just about as high as any of the females in that group. Ha ha ha. Get rid of that. Let's see what else we can do with this. Click. Next. Full question. The probability of obtaining a head when a certain coin is flipped is about 0.65. Now, obviously, typically you think 0.5, but they're telling you that this is a weighted coin. They're telling you that. Which of the following is closest to the probability that heads would be obtained 15 or fewer times when this coin is flipped 25 times? I'm going to need a calculator for this one. I'm going to suggest that you get one too from your Chromebook. Now, this is a probability question. We dealt with probability in December, January, mostly probably January, a little bit of February. That's when the probability chapters came in. You have a fixed probability. You're trying to see if you get 15 or fewer heads. Those are your successes. And you're only flipping the coin 25 times. That is a set number of trials. This sounds to me like a binomial problem. So here's what I'm going to say. I'm going to suggest that you attempt to go to binomial, which means you hit second vars. Second vars will take you to the two binomial functions. I'm going to let you finish the rest of the problem from there. Second vars will take you to the binomial functions, and I'm going to let you finish that one out. Hopefully that helps a little bit. Oh, bless you. know why people say bless you when you sneeze? They're afraid that your soul will escape out your mouth. Saying bless you pushes it back in. Didn't know that? Whatever. I'm always full of weird knowledge. I'm also usually full of it. We're waiting on 8 people. 7. When you take that multiple choice on May 25th, don't worry what other people are doing. You ever take a test with multiple pages and then you hear somebody like triumphantly turn the page? Yeah, that can be a little bit demoralizing. Don't screw them, even though they're your classmates sitting around you right now. You go at your own pace, you get your stuff done, but you try to stay within that time limit. It's a weird balancing game. Wait, I answered, right? Yes, I did answer. Okay. Come on, I'm waiting on 2 people. Then I can show you. Well, while you're doing that, I'm going to bring up my calculator. I'm going to bring up my calculator right here so that those people can finish answering, but you can see what I'm doing here. I mentioned bringing up second vars and going to your binomials. The one that you really need to focus on for this problem is binomial CDF, the cumulative function. The reason why you want that cumulative function is because it's 15 or fewer, meaning 15 or 14 or 13 or 12, etc. Now, keep in mind, I'm still waiting on that one person to answer. I'm just going to stall for time until they do. Not really giving away too much. There they go. There are 25 trials with a 0.65 probability of success. And because I'm doing CDF 15, if I type 15 in there, it will do 15 or fewer. And you can see how that's typed in right there. Chappelle, about 37%. And yes, that is where that 37% came from. And you can see people who chose that right there. But that is exactly how that calculation was done. It always goes the N value, the number of trials, the probability of success. Now, mind you, each trial has to be a fixed probability, meaning there has to be independence between one trial and the next. As long as there's independence between one trial and the next, that 65% will remain fixed. And then that last number, 15, that is the number of successes. If you just did binomial PDF with the same numbers, it will spit out 14%. But PDF is getting exactly 15 successes. PDF is getting exactly that many successes, whereas CDF, cumulative, is getting 15 or less successes, meaning it's adding up all of them from 15 to 14 and 13 and 12 all the way down to 0 successes and finding a cumulative probability. Oh, nice. They even had 14 as one of the answers. Again, just to troll with you. Next question here. Chappelle. Sweet. The buyer for an electronics store wants to estimate the proportion of defective wireless game controllers in a shipment of 5,000 controllers from the store's primary supplier. The shipment consists of 200 boxes, each containing 25 controllers. The buyer numbers the boxes 1 to 200 and randomly selects 6 numbers in that range. She then opens the 6 boxes with the corresponding numbers, examines all 25 in each of these boxes, and determines the proportion of the 150 controllers that are defective. What type of sample is this? Now, I'm trying to debate what kind of clue I want to give you. Obviously, this is not convenience. Convenience would make it easier for the person actually conducting the sample. Clearly, the person conducting the sample went through a bit of hassle to kind of go through this. It's interesting. I might think in my travels, I might think of a Boston cream pie. Something along those lines. Those are really good, though. I'm going to go put in my answer while you guys put in your answers. Got 3 to go, 2 to go, 1 to go. I mentioned Boston cream pie for the simple reason of when I brought up the Boston cream pie, I was talking about cluster sampling versus stratified sampling. When you have stratified sampling, you are separating the population into individual strata where within that strata, there's a homogeneous relationship. For example, if I took the Barnegat population and I separated you into freshman, sophomore, junior, senior, I would be splitting you up to your individual strata. Meaning, well, if I'm in the freshman group, that means if I'm separated to this group, then there's only freshmen around me. If I'm separated to the senior group, then we all have that in common, the senior ability or whatever it's called. I don't know. But if you're split up to your individual strata, then a little bit could be sampled from each. So here's the cream, here's the chocolate, here's the Boston. Let's sample a little bit from each of them. Whereas with a cluster sample would be taking a slice out of that Boston cream pie with the hope that that slice is representative of the entire population. That's exactly what they did. That slice, in this case, represents one box. They took out one box, and then they sampled things within that box. Or actually, they took out 6 boxes, I think. Yeah, they took out 6 boxes randomly, and those were 6 slices. This was a cluster random sample. There we go. So it wasn't stratified. Like I said, it wasn't convenience. It would only be convenience if the guy's like, yeah, just give me the first box and I'll just look at all of them. Yeah, that would definitely be convenience. Next question. Let's see here. Ooh, interesting. This one hopefully shouldn't take too long. Which of the following scatter plots, linear regression, chapters 6, 7, 8, and 9, which of the following scatter plots could represent a data set with the correlation coefficient of R equals -1? I'm just going to let you pick that one. I mean, obviously, I already know more than half of you have already picked an answer, so I'm just going to let you finish that one. I got to go pick my answer. Let's see here. Now, it's interesting because if it's R equals -1, course, the R value can go all the way from -1 to +1, -1 and +1 being the strongest linear relationships. It would have to be a perfect straight line. And the only perfect straight lines here are the first, third, and fifth choice. This right here, this would have probably an R value of 0. This one, it would be really weak. It would be really weak, but maybe it's like 0.1 or some junk like that. Whereas the rest of these are almost perfect straight lines. The negative sign on there indicates the direction of that slope, in this case, the first one here. What's interesting is that I've tried doing correlations with this right here. I want to show you something on my calculator real quick. I've tried doing correlations with a horizontal line. I left that calculator up there. That's okay. Actually, no, I'll do it here. Okay, here we go. So stat edit 1, 2, 3, 4, 5, and I'll do 3, 3, 3, 3, 3. Nope, there we go, 3. So I have a scatter plot, zoom 9 it. There we go. Oh, let me get rid of that. Doing that in algebra. Zoom 9 it. There's my horizontal line. Let me turn my diagnostics on so that I can actually get an R value if need be. Diagnostics on. Run the linear regression. Ha! It won't calculate an R value if you have a horizontal line. Yeah, it won't. It can't say a positive and negative at the same time. If it were sloping upward, they'd say +1. If it were sloping downward, they'd say -1. What the heck do they say for a horizontal line? Some people would immediately be like, well, shouldn't they say 0? No, because 0 is where you have no correlation whatsoever. And this thing obviously does have some linearity behind it. But because it's a horizontal line that has 0 slope, it's not possible to actually produce an R value. Yay. Weird. Next question. Chapow. An environmental scientist wants to test the null hypothesis that an anti-pollution device for cars is not effective. Under which of the following conditions would a type 1 error be committed? Type 1 error is saying, I don't trust you, parachute, but you're wrong, and you don't get to skydive. Sad days. That's the only hint I'll kind of give for this one. Oh, I got to give my answer too. Hold on. Oh, the wording on this is so interesting. Oh, the wording on this. I'm pretty confident on the wording of this. And if it says that I'm wrong, I can argue that I'm right. Click. It says I'm right. Let's talk about why. Let me see what you guys chose. Click. Ooh, interesting. Okay. Null hypothesis versus the alternate hypothesis. Now, check this out. He is testing an anti-pollution device. think to yourself what this anti-pollution device is trying to do. This anti-pollution device is trying to reduce, I'm assuming, the emissions on this car. You're testing to see whether or not this anti-pollution device does what it's supposed to do. The null hypothesis is there's nothing going on. There's no difference. So we could say the null hypothesis is the device makes no difference. Whereas the alternate hypothesis was device works, or it's effective, or whatever you want to call it. But the null hypothesis is there's nothing going on, nothing to see here, no difference between the old device and the new device, or whatever the heck you want to call it. Type 1 error would be saying, I reject that null. I reject that null, and here come the consequences. Well, if you reject that null hypothesis, you're basically saying that the device works. You're basically saying evidence shows that the device is effective. But if you're wrong, then the scientist concludes that the device is effective when it's actually not. That would be that type 1 error. Type 2 error would be saying, it makes no difference. You're saying the device is not, you're saying the device is not really effective when it actually is. That type 2 error, that's actually what 7 people chose right here. This is actually the wording of the type 2 error. It concludes that the device is not effective when it actually is. That's the worst error, because then you could have been preventing pollution. Whereas in the first one, it's like, it's a mistake, but not as bad. Okay. The wording on that was fun. I enjoyed that. Next question. I'm probably only going to do a couple more questions, and then I would like to get to chi-squared. A data set of test scores is being transformed by applying the following rule to each of the raw scores. Transform score 3.5 times the raw score plus 6.2. The question is, which of the following is not true? Now they're talking about individual data points and what happens to them along the way. I will say that there are certain operations that affect measures of center, and there are certain operations that affect measures of spread. A measure of center would be like mean and median. A measure of spread would be like standard deviation, ranges like IQR. So what operations affect one over the other? I'll leave you to it. Oh, I gotta pick my answer too. Let's see. Which of the following is not true? Pretty sure I clicked that, right? If I didn't, I'm going to be silent. Wait, now one more. 19 out of 20. I already clicked mine. Trying to will my powers. It's not working. Come on, I'm still waiting on one person to do that thing. So we can see what that answer was. Well, while they're doing that, let me talk about some of the stuff. First of all, let's just pretend that you had some kind of normal distribution, some kind of distribution of data where you could measure the mean is approximately in the middle. And there's like, oh, the standard deviation, there's plus one standard deviation right there. The standard deviation measures the spread. The mean measures the center. If you were to, let's say, add a certain number to every single data point, that would shift this whole thing over from, like, let's say it was like 3, and then now you add 6.2, and now that mean is at 6.2 or 9.2 now. It's been shifted over. But the measure of spread remains exactly the same. It remains exactly the same, even if it's been shifted over by adding or subtracting. Adding or subtracting will affect mean and median and the individual data points. It will not affect measures of spread. It will not affect, adding and subtracting will not affect standard deviation, interquartile range, or the range. And if you notice, for these two statements right here, standard deviation and IQR, they just said that the standard deviation of the transform scored equals 3.5 times the standard deviation of the raw scores. They did not even account for the 6.2. Neither did the IQR. Those two statements are correct. Those two statements are true. If I look over here and I look at the mean and the median, both of those multiplied by 3.5 and add the 6.2, yes, measures of center are affected by all four operations. The only one that is not true is that middle one, the range. Still waiting on number 20. I don't know if they were able to answer. I answered mine. I don't know. But yeah, the answer should have been the middle one. Maybe I can actually click them off. Hold on. Let me see here. Click. End question. Cool. So yeah, I'm going to end the question there. Yeah. I do not. Did it die? Oh, I gotcha. Yeah, I do not have an extra one. I'm sorry. I'm going to be done with the question after this one, though. So you should, well, I don't know what you can do for the rest of the day. End that question. All done. Oh, there he goes. Yes, and you can see that middle one right there, the range. Interesting. I enjoy this thing. I don't know. I haven't tried this yet with other classes, this instructor pace thing, but that's kind of interesting. I like that. Because then you can actually talk about each question. It's kind of like, you remember what Kahoot used to be? You remember how Kahoot was dumb? I see several people nodding yes, several people nodding no, several people getting on their Kahoot bandwagon. Just saying. Anyway, we'll pick up with more of this next time. Now, again, what I'm going to try and do as time goes on is I'm going to try and incorporate various aspects of review from previous chapters into lessons. Now, obviously, Wednesday I was out. I wanted to make sure that I went through a bunch of the stuff with you. Now, as time goes on, I will also eventually be throwing minors at you from previous chapters of information. I will be giving you the heads up, of course. This is not going to be like a pop quiz anything. No, 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 no. I will give you plenty of heads up before I give you something like that. But just be forewarned that I will be reviewing previous chapters slowly but surely with various things. Anyway, in the meantime, I'm done with the Chromebooks for now. If you would be so kind, I am going to ask for those notebooks to be out and open. There we go. This make it a little bit easier to see stuff. There we go. And bring my stuff over here. Let's see here. Oh, that's where that thing went. You should use that one day. Might try that. Okay. Click. And click. Today is actually the last day in April, believe it or not. Now, this is an intro to chi-squared. I'm going to be showing you one major aspect of chi-squared today. And I'm going to save the other aspects of chi-squared for another day. And yes, just for the sake of argument, that is chi, not chai, not chi. It's chi. Chi is a Greek letter. Let me show you the Greek letter. Hold on. Greek letter chi. This images, I know, looks like an X, but in reality, that's the way that I'm going to draw it. It's a chi. I'm going to draw with that curvy thing there with a line through it. Chi-squared. On your calculators, just for the sake of argument, there's two locations that you can talk about chi-squared. On these calculators, you have two chi-squared tests. You have a regular chi-squared test, and you can see that symbol there. And you have a chi-squared Goff test. If you read the chapter, you would know what Goff stands for, but we'll talk a bit more about that today. If you go into the regular chi-squared test, have you ever seen symbols like that on the calculator around the A and B? Do you know what those are? Those are matrices. Those are matrices. That's not the lesson we're doing today. I'm not going to talk to you about the matrices today. The matrices are going to be the next one where we do the test of homogeny. But I can't even pronounce it. It's like homogeneity. There it is, homogeneity. But that's for another day. When you go to the other chi-squared test, if I could actually get there. Come on. The goodness of fit one. Notice they give you L1 and L2, which you should be a bit more familiar with. Those are lists. But we'll deal with that today. The other location that you can find chi-squared information is if you go second vars. Second vars, you can see right there, options 7 and 8. Chi-squared PDF, chi-squared CDF. I'm going to show you chi-squared CDF today. PDF is not one that we ever really go into for this class, just like we don't go into normal PDF. We only use normal CDF. Similar rationale there, but we'll get into that. Should be interesting. Now, just for the sake of argument, again, I do have to show you this. And I'm going to talk about eventually how we're going to get around this. For the AP test, for the actual AP test, you may need to have these handheld calculators. And obviously, I have a ton of TI-83s. But the problem is, if you go down on the TI-83, what do you notice about the chi-squared test? There's no Goff. There's no goodness of fit. There's only one of them. Oh, man. I know, right? When you go second vars, they're both still there. Second vars, they're both still there. You can see that right there. So that's no big deal. And that actually might help us out in the long run. Being that they're there, I mean, we may have to do some extra work. And I'm going to show you how that extra work could actually play out. But again, like I said, there's no guff. So we have to do one of a couple things. If you do need a chi-squared test for this AP thing, then we need better calculators to get that goodness of fit test, or you have to learn how to do the alternate way of going around it. But we'll cross that bridge when we get there. I just want to make sure you're aware of that. So zooming out, zooming out, zooming out. Get this little thing right here. Come here, you. Come on. There we go. Good. Okay. So in the chapter, I said in my instructions that I was going to go over one of the examples that you read throughout that chapter. And the one that I wanted to talk about was the earlobe versus tongue rolling genetic theory. I like that theory. I think it does explain a bit of what I want to do here. But let's talk about it. So tongue roll versus earlobe attachment. Now, it's one of those things where it's like, legitimately, there are some people who can't roll their tongue. Sorry, you might be some of them. We'll never know. You're wearing masks. But right now, I guarantee you, at least a quarter of you rolled your tongue underneath your mask. Yep, several people are nodding yes. Okay, great. Now, earlobes, obviously a bit different, you know. I have a detached earlobe, a free-flowing earlobe, whatever. I don't care. My sister has a weird earlobe. It's not about like attached or detached. She has a weird earlobe where literally the top portions of both of her ears are like folded down a little bit. It's very strange. I don't know. It's like I thought she was Elven. Oh, you guys don't get that reference. Lord of the Rings, nothing? You guys are weird. Anyway, back to this. Genetic theory predicts that people will have neither one or both of these traits in the ratio 1 to 3 to 3 to 9. And I'll explain what that means in the chart that I'm about to give you guys. These traits, the ability to, the inability to curl one's tongue and having attached earlobes. In fact, it's very common for most people to be able to roll their tongues. Common. It's most common for people to have free dangling earlobes. Most common. But what they say is this. Here's a little chart that I'm going to give you. Tongue versus ears. You can have a non-curl attached. Non-curl attached occurs, well, 1 out of 16, or 1/16 of the population. That's not us. This is the predicted fraction. Move that up a bit. You could have a non-curl free earlobe, and that occurs in 3/16 of the population. You could have the ability to curl your tongue with attached earlobes, and that's a 3/16 fraction. Or you can have, and this is the most common, is you can have the ability to curl your tongue and free dangling earlobes. And that's 9 out of 16, or 9/16 of the population. Move that up a bit. That's where they get that ratio 1 to 3 to 3 to 9. They get that ratio from the idea that it's all out of 16ths of the population. It adds up to 16 out of 16, of course. But that's where they get that ratio from. So if you ever meet someone who cannot roll their tongue and has attached earlobes, that is kind of rare. That's only like 1 out of every 16 people. Like legitimately in this classroom, there might only be 1 or 2 people who have both of those traits total. I don't know, I find that interesting. I mean, obviously it could be 0. I'm talking about expectation based on the fact that it's out of 16. Well, whatever, it happens. It's so weird. It's like with your earlobe, it's like, I don't know. It's cartilage, right? It's like, oh, this part's cartilage?
Yeah, this.
It's not? Is that why, like, when I squeeze my earlobe, it hurts? Okay, so check this out. You could squeeze your earlobe, and if you squeeze it really hard, you could actually get it to hurt a little bit. But if you go to the top of your ear and squeeze the same amount of pressure, it doesn't. Try it. Just saying. Am I right? Yeah, isn't that weird? Are there more nerve endings down here? Then why do you girls like shove spears through them? Just saying. It hurts. Anyway, whatever. My wife, if you look at her, it's just like, oh yeah, that's a mom right there. When she was in high school, she had multiple earrings going up the side of her ear. She had plans for gauged earrings at one point. It was really insane. But now it's like you look at my wife now and you're like, no. But yeah, she did that kind of stuff. It was great. Anyway, back to this. So according to the example that they gave, there were 124 students in a bio class. And we had a certain expectation. The expected counts with n equals 124. We had a certain expectation. If there were 124 students and you multiply 124 times all of those fractions, you get the following numbers: 7.75, 23.25, 23.25, 69.75. If this bio teacher looks at all 124 of the students, well, we have expectation versus reality. The expectation being these numbers, and now here's the reality, or what we refer to as the observed counts. It's kind of like linear regression when you were dealing with residuals. Residuals were going to end up being observed minus predicted. That was the residual with linear regression. Observed minus predicted. If you got a positive residual, that data point was above the prediction line. And if you got a negative residual, then it was below the prediction line. But that's neither here nor there. Here are the actual observed counts: 12, 22, 31, and 59. 12, 22, 31, and 59. Now here comes the question. Here comes the question, which basically forces our hand behind using a chi-squared test to answer it. Bring this over. Come on, paper, be my friend. I'm going to put a little asterisk next to here. It's not as important as a star. How closely Do the observed numbers fit the expected model? How closely do the observed numbers fit the expected model? Now, under the word expected, I'm going to put the word null in parentheses because technically speaking, according to this genetic theory, we should have the ratio of 1 to 3 to 3 to 9. That is the null hypothesis. That's the claim that is innocent until proven guilty. The expectation or the expected counts are going to act as our null hypothesis. I mean, obviously, we're going to word it differently, but they act as our null. Now, I asked this question, how closely do the observed numbers fit the expected model? Or do the observed numbers fit the null close enough? And I'm going to put close enough in parentheses. Do the observed numbers fit the null close enough? So if I look at the observed counts, I'm just going to slide my paper back down a little bit. If I look at the observed counts on the top right side of this page, we were expecting 7.75 for non-curl attached, and we got 12. We were expecting 23 and a quarter, we got 22. That's pretty close. 23 and a quarter, we got 31. That's a bit more than we thought we were going to get. And then we were expecting 69.75, and we got 59. That's a lot less than we expected. Is there something unusual going on about this class? Or is this just the result of sampling error? Just random variations within each sample? If I got another random sample of 124 students, would my numbers fit a bit closer? Or is this usual for just sampling variation? I don't know. We may have to run a hypothesis test. Now, a couple of notes down here. There's no population parameter to estimate. There's no population parameter to estimate. So, no confidence intervals. Can't do that. There are 4 hypothesized proportions. So we can't do a 1 or 2 prop z-test. There are 4 hypothesized proportions, 4 categories of non-curl attached, non-curl free, curl attached, curl free. So we can't do a 1 or 2 prop z-test. We can't. We only have one option in this case, and it is a chi-squared goodness of fit test. That's what we're going to have to do. It's a brand new test. Chi-squared goodness of fit is, number one, you have to have categorical data. You have to have categorical data in this case. And we have those counts, so to speak, those counts of like, okay, this is how many people fit into this category. This is how many people fit into this category. Doesn't make sense to take an average of these counts. What's the average ear and tongue look like? We can't do that. It's categorical data. But I'm looking at, do the observed data fit the null close enough? This is a goodness of fit model. That's exactly what we're going to do. So let's walk ourselves through a hypothesis test. First, the null hypothesis. Now, the null hypothesis is not going to look exactly the same as it did in the past. I'm going to have to write out a little sentence here. The traits occur in the predicted ratio 1 to 3 to 3 to 9. That is my null hypothesis. There's nothing going on. There's nothing out of the ordinary. Innocent until proven guilty. The traits occur exactly as they believe they will. That's my null hypothesis. That is what we will eventually either reject or fail to reject. My alternate hypothesis. My alternate hypothesis is, well, the traits don't occur as predicted. They don't. They just simply don't. That's my alternate hypothesis. Again, I'm just trying to use the context of the situation here. The idea of the null is, again, nothing is going on. Innocent until proven guilty. Show me the evidence that either supports it or goes against it, etc. And then I'll come to a conclusion. All right. Assumptions and conditions. Now, for the sake of argument, I'm going to list these out. I'm not going to put them into context today, but I just want to list with these out for a chi-squared goodness of fit. So I'm going to go chi-goth, because that's what the assumptions and conditions that we're doing with. Whenever you say goth, you have to say it just emphatically like that. Put the emphasis on the wrong syllable. You'll get that later. First of all, counted data must be counts of categorical variable. You must have counts of a categorical data. That is a must. You must have counted data. That is a condition. If you don't have counted data, then, well, we're going to have an issue here. Independence. Independence is always a big deal. Independence is always a necessity for what we are trying to accomplish. Basically, responses are independent of each other. Now, obviously, like, I don't know what the genetics is. I don't know how it passes on from one person to the next. I don't know where, biology and all that junk. But obviously, if you have somebody who has a certain trait in earlobes and a certain trait with tongue rolling, it's possible that those traits are passed on to the children. And if you were sampling a family, that wouldn't be random. In order to guarantee independence, it's got to be a random sample. As long as you have a random sample, then you can say, yeah, this person's earlobe and tongue rolling abilities do not affect this person's earlobes and tongue rolling abilities. And that way we can ensure independence. You need to have randomness of selected individuals. That's a given. We've been talking about that from day one. There has to be a certain level of randomness. At this point, it's kind of a given. You also need to talk about the 10% condition. It's the same 10% condition that we have always talked about. Your sample should be less than 10% of population. This marker's dying on me. If that thing wasn't in the way, it still would have missed. So, but the sample should be less than 10% of the population. Now, this guy took a sample of 124 students in his bio class. I mean, I guess I don't know what his population really was. I don't think they actually said it. I mean, maybe they did, but the assumption could be like, okay, well, is it 124 students out of the school? Because if that's the case, then yeah, less than 10% of the population. Are you talking about the population being that age bracket of students? Then yes, absolutely. That would be less than 10% of the population. Finally, brand new, here we go. You need at least 5 expected in each cell. Now, the cell is just the individual category. We have 4 different things that we're kind of choosing from here. Non-curl attached, non-curl free, curl attached, curl free. But you need at least 5 expected in each cell. That is similar to that of needing at least 10 expected successes and 10 expected failures. Similar idea, except in this role, you need at least 5 expected in each cell. If you don't have 5 expected in each cell, then we're going to have a little bit of an issue. Cool. Bring this back up. There we go. So we're going to perform a goodness of fit test. If we hit all of those assumptions and conditions, then we are allowed to go ahead with the chi-squared goodness of fit test. If you were performing a z-test, then at one point you would calculate a z-score. If you were performing a t-test, then at some point you may calculate a t-score. There is a test statistic for chi-squared. I'm going to draw it very carefully. There's my chi squared is equal to the following calculation. It is the sum of all cells, which in this case we would be doing 4 cells, of the following calculation. Observed minus expected squared divided by expected. This is the calculation of chi-squared. There are a lot of multiple choice questions that I've skipped over this, but this is, obviously we haven't gotten to it to this point, but on those multiple choice questions, they show this use of the formula over and over again when they give you the answer. But this is how the calculation is typically done. Now, what I want to do is I want to go to the calculator and actually just perform this test real quick. And then next class, I'm going to walk you through the steps as to how you would do it using the lists in your calculator. But first, I actually do have to enter some of this data. So let me go to list 1. I just reset the thing. Second plus sign 712. There we go. Stat edit. There we are. Where's my info here? Okay. Observed counts are 12, 22, 31, 59. Those are my observed counts. Here's my expected counts. 7.75, 23.25, 23.25, 69.75. Those are my expected counts. If I now go back to the chi-squared goodness of fit test, which we will get to next time, of course, you can see the order. Look at the order in which stuff was in there. Observed, expected. That's the exact order I did. Degrees of freedom. America. See, the thing is, there were 124 students. Sorry, your degrees of freedom are not 123. It's not. The degrees of freedom for chi-squared is n minus 1 for the number of categories. We had 4 categories. So I got to put a 3 in there. Then I'm going to go ahead and calculate this sucker. Now, we're going to write this down next time, but I just wanted to show you this. P-value. 0.084. There is not enough evidence. There is not enough evidence to show that the genetic theory is wrong. There's not enough evidence to show that it's wrong. I would fail to reject it, although there is a little bit of evidence. I mean, it's close. That's why I would say there's not enough evidence. Yeah, because the p-value is greater than 0.05, I would fail to reject the null hypothesis. In conclusion, there's not enough evidence to show that the genetic theory of earlobe to tongue roll traits is wrong. There's not enough evidence to show that it's wrong. And then we'd all dance. I'm going to show you next time how we would calculate this chi-squared number. I'm going to show you next time how to use chi-squared CDF. It's going to be fantastic. We'll deal with all of that on Tuesday. Yeah. All right. If you haven't left a comment in the chat, please make sure that you do so. That would be wonderful and fantastic. And then we'll see you all next time when the bell rings in about 2 seconds. That was off. There we go.